Hello everyone. So the next topic which we will be discussing is about the ecological efficiency. So let's start with the introduction that what this topic is all about. So the ecological efficiency, it describes the efficiency with which the energy is transferred from one trophic level to the next. So it is being determined by a combination of efficiencies which is relating to organismic resources, acquisition and assimilation in an ecosystem. So it is basically describing the efficiency with which the energy is being transferred from one trophic level to another. So this is a pathway of showing the ecological efficiency only, that the energy is being transferred through trophic levels. So there will be a transfer of energy from one trophic level to another. So first of all, the primary production, which occurs in autotrophic organisms of an ecosystem. There are photoautotrophs such as vascular plants and algae that convert the energy from the sun into the energy which is being stored as carbon compounds. So photosynthesis, it is being carried out in the chlorophyll of the green plants. So the energy converted through photosynthesis is carried through the trophic levels of an ecosystem as organisms consume members of lower trophic levels. So primary production can be broken down into gross and net primary production. So if I talk about the gross primary production, then it is a measure of the energy that a photoautotroph harvests from the sun. For example, a blade of grass that takes in X joules of energy from the sun. So that fraction of energy is converted into glucose and it reflects the gross productivity of the blade of the grass. So the energy remaining after respiration is considered the net primary production. In general, if I talk about, so the gross production refers to the energy which is being contained within organisms before the respiration, and the net production, the energy after respiration. So the terms can be used to describe energy transfer in both the autotrophs and the heterotrophs. So energy transfer between the trophic level is generally insufficient, such that the net production at one trophic level is generally 10% of the net production at the preceding trophic level. So due to the predatory death, egestion and cellular respiration, there is a significant amount of energy which is being lost to the environment instead of absorbed being absorbed for production by the consumers. So the figure which is representing here, it approximates the fraction of energy available after each stage of energy loss in a typical ecosystem. Although these fractions vary greatly from the ecosystem to ecosystem and from trophic level to trophic level. So the loss of energy by a factor of one half from each of the steps of the non-predatory death, defecation and respiration is a typical of many living systems. So thus the net production of one trophic level will be 1 by 2 into 1 by 2 into 1 by 2, which is equals to 1 by 8, or approximately 10% of the trophic level before it. So for, if I take an example here, assume that there are 500 units of energy which are being produced by trophic level 1. So one half of that is lost to non-predatory death, while the other half, that is the 250 units, is ingested by the trophic levels. So one half of the amount ingested is expelled through defecation, leaving the other half to be assimilated by the organism. So finally, one half of the remaining energy is lost to the respiration, while the rest is used for the growth and reproduction. So this energy is expanded for growth and reproduction, and it constitutes the net production of trophic level 1, which is equals to 500 into 1 by 2 into 1 by 2 into 1 by 2, which is equal to the 63 units. So this was all about the energy pathways through the trophic levels. The next I will talk about the how to quantify the ecological efficiency. So ecological efficiency, it is a combination of several related efficiencies that describe the resource utilization and the extent to which resources are converted into biomass. So exploitation efficiency is the amount of food ingested, which is being divided by the amount of prey production. So In divided by Pn minus 1. So the next is about the assimilation efficiency, which is the amount of assimilation divided by the amount of food which is being ingested. So An divided by In. The next is the net production efficiency, which is the amount of consumer production divided by the amount of assimilation. So Pn divided by An. Next is about the gross production efficiency, which is the assimilation efficiency multiplied by the net production efficiency, and which is equivalent to the amount of consumer production divided by the amount of ingestion. So Pn divided by In. So these are some of the formulas, so that it can be easy for us to how to calculate the ecological efficiency. So the last is about the ecological efficiency, which is the exploitation efficiency multiplied by the assimilation efficiency and multiplied by the net production efficiency, which is equivalent to the amount of consumer production, which is divided by the prey production. So Pn divided by Pn minus 1. So theoretically, so these are some of the formulas which I have just told you. Theoretically, it is easy to calculate ecological efficiency using the mathematical relationships above. It is often difficult, however, to obtain accurate measurements of the values involved in the calculations. So accessing ingestion, for example, requires knowledge of the gross amount of food consumed in the ecosystem as well as its cal caloric content. So such a measurement is rarely better than an educated estimate, particularly with relation to the ecosystem that are largely inaccessible to the ecologists and tools of measurement. So the ecological efficiency of an ecosystem is as a result often no better than an approximation. So this was about the quantifying the ecological efficiency through some formulas. The next is about some of the applications of the ecological efficiencies. So in agricultural environment, the maximizing energy transfer from producer to consumer can yield the economic benefits. So a subfield of agricultural science has emerged that explores methods of monitoring and improving ecological and related efficiencies. So in comparing the net efficiency of energy utilization by cattle breeds historically kept for beef production, such as Hereford, outperform those kept for the dairy production, such as the Holstein, which has been converted to energy from the feed and that is being stored into the energy as the tissue. So this is a result of the beef cattle storing more body fat than the dairy cattle as energy storage as protein was at the same level for both the breeds. So this implies that the cultivation of the cattle for slaughter is a more efficient use of feed than is cultivation for milk production. Next is about the 10% law. So the 10% law is the transfer of energy from one trophic level to the next, and according to this law, during the transfer of organic food energy from one trophic level to the higher or to the next higher trophic level, only 10% of the transferred energy is stored as flesh, and the remaining is lost during the transfer, broken down in respiration, or lost to incomplete digestion by higher trophic level. So here you can see there is 100 joules of light energy which the plants are getting from the sun. So that will result in the 10 joules of energy which is available as food for the producers. After this, 990 joules is being lost to the environment, and there are 100 joules of energy which is being gone to the animals. Out for that, there is a 1 joule of energy which is available as food for the herbivores, uh, and the 9 joules of energy is lost to the environment. The 1 joule of energy is given to this animal, that is the carnivores, and only 0.1% energy is available as food, and 0.9 energy has been lost to the environment. So this is how a 10% law works. So this was all about the ecological efficiency. These are some of the references. Thank you.